Okay, so a lot of you has question about the Gran 2 plot. Okay, so if we're going to look at the example that we have there, the Excel that I uploaded, there's really no equation that's written there because it's not easy to put them in one cell. But I showed you how this is being done during our class last time. Okay, so if we're going to look at this thing, so this is the formula that you have for the Gran 2 plot. So you have 10 raised to the difference of pH minus pKW, which is 13.997 times BI plus BB equals to FB, okay, times BB minus BE. So we could say the formality is your slope, the y-intercept, the x-intercept that you have there is your BE, okay? So if you're going to remember, okay, so it's 10 raised to the pH minus pKW times BI plus BB over the formality of your base times BB minus BE. So most likely we could say this is your X, this is your y-intercept, okay? This is your slope, and this is your whole Y. So the way I did it in our class, I just get this one, and then this one, and then that's the time I'm going to combine them. So BI is what? That's the volume initially, and I think that's around what? 25 ml. Now BB, this is the base volume that you add. Now pKW, that's the 13.997. And the pH is the corresponding pH that we have. So if we're going to look at the Excel for this, okay, so I put already some stuff here, but we can start from scratch on that one. So pH minus pKW. So you have here the pH, okay? So equals to pH minus 13.997. So I have a negative here. And I just drag them down. So they're changing because the pH here is changing. Now for this one, I have 25, and then I add it with the volume of the base that you have there. And then I drag it down. Okay, so here, how did it end up there? So the way that we're going to do is, remember, I have 10, and then I raise it. So I hope you see the symbol that I use. You raise it to the difference between pH times pKa, and then you multiply it with the BI plus BB. And then you what we call drag it there. Now, if we're going to plot here, the Gran 2 plot, so as you could see here, okay, so this is the plot that you have. So this is similar to what? The one that is being shown in the experiment, which is this. See that? So right away, you can get the x-intercept. And what you're going to do is you're going to fit it to the linear part. So you're going to get to be able to get the slope to this one. So it would be around this portion here. Now, if you want to get the linear part of it, you can just drag it down. Okay, we got one, 19.1. Oh no. Okay. So once I have that, I can get what? Trend line of that, because I need the one that is linear. So if you're going to have it here, so we can say the formality here is the slope, the 0.2783. Okay, so that's just one way to get data from your experiment. So that's experiment 3. Okay, now on the other hand, for experiment 2, I already put everything here. So the idea here, this is the part 1, this is the part 2, and this is the part 3. Okay, so you have the concentration used here. So the one that you have, okay. So if you're going to do it, you're given a lower concentration of this one. Okay, now you're going to determine how much you're going to use from the higher concentration to prepare your target one. And usually it's not exact, so you can put here the predicted one, and then from the predicted concentration, you now compare it with the measured concentration. The measured concentration is just what? Whatever the absorbance divided by 5. So here, you do the same thing, but this one is, remember, you cellular dilute it 1/4 at a time. Okay, so you're going to include that portion here. Now, the allowed range that you have, so you have your predicted based on the 1/4. So you compare it, if it's within the value that you get for the measured. If not, then what would be the difference? Now, the ratio that you have here is just your measured concentration, the highest one, divided by the lowest one. Okay, both measured. Okay, so that's it. Hope you understand in doing this for your Excel part.